And I think I touched based upon this discussion earlier, but overall, in the PPP partnership, particularly in India, this is being ignored on a very large scale in terms of the deployment of when we talk about any kind of solar power to be deployed. There's something called silicon duping. I'll be walking you through that. For that, we'll just wait for a few more minutes. In the meantime, I'll just fetch some data sets. So yeah, we'll just go through that data set right away. Okay, we'll be talking about the silicon stuff and particularly with the preparation method of P-type back contact crystalline silicon stuff. Now, this work or this kind of work in terms of understanding silicon duping, you have to look into firstly into the data sets of. Okay, we were talking about this climatic change and particularly in the landscape of India. Right now, due to the different governmental schemes, including from the government banks, including SBI and stuff, there's a lot of deploy there's a lot of deployment of solar panels. And folks are forgetting the main aspect of the duping process. For that, you need to look into the patenting landscape of the company Applied Materials, which is based out in US or headquartered in US, though they have their some kind of standing in India. However, I will walk you through some of the technological landscape in terms of the patenting, and this patenting landscape comes from China. We have to understand one thing: due to this whole COVID situation and stuff over the years, the point of contention here is. Okay, anyhow, so the point here is the Chinese patent application, which one needs to look into is CN 1133 63354. So this is basically the title. I will give you the application link after this video, which is titled "A Kind of Preparation Method of P-type Back Contact Crystalline Silicon Solar Cell." So I'll just look into it and I'll tell you what this innovation is all about. And probably I'll go through 4 or 5 applications because right now we need to stop this solar implementation in terms of where silicon is used. Because silicon duping itself creates a lot of, I would say, in the atmospheric stuff itself, it creates that kind of, I'm trying to use non-technical terms here. So if I have to use a non-technical term, it would be due to silicon duping, this whatever heat up air we are seeing, that is a result of that. People who understand that kind of technology, because this is not a technology of PhDs or something, it has a lot of research, a lot of people over the globe have been doing this, and particularly, although at one point of time it was Applied Materials, but today we have loads of companies from China. So this particular company is Zhejiang Alco Solar Energy Technology Co. And it is an association with a couple of technological solar companies based out in China. So I'll just fetch the data set for the folks so they can just review that whenever they look into this video at some point of time. So if you have any questions related to this, I'll be happy to walk you through that. So it's basically the method of fabrication. And generally, what happens in India is the assembly part. So even if the assembly is happening in India, we or on a larger scale, even a point difference which is very minute to the human eye, that makes a lot of difference when the deployment is done, because the heating capacity of the solar cells, particularly the silicon doping, it creates a lot of tension around the air itself. So this basically innovation is specifically, as I said, it is p-type back contact crystalline silicon devices. It is one step wafer polishing and thermal growth on a silicon oxide layer on a P type silicon wafer. Then we have deposition of intrinsic or lightly doped amorphous silica, that is A dash silica layer on the wafer back. Then the application of a patent deposited mask to determine and define the contact regions. Then we have local laser albation through the mask to form openings of a um, amorphous silicon layer and oxide stack. So alkaline and acid texturing is done, annealing is done to crystallize the process, rear side deposition is there, screen printing and inkjet printing of positive and negative rear electrodes followed by co-firing. So what are the key advantages of this particular innovation? It eliminates the ion uh, implantation steps. So whatever the steps which are involved in the ion implantation, that is avoided in this innovation itself, reducing the capital expenditure and the process complexity. So it makes the process easy per se. Reuses the existing PRC production lines with minimum manufacturing cost, because most of the innovations which are developed, they take two things into the criteria. One is the low cost. Obviously the low cost is achieved when anything is done in bulk, and then the first move advantage, and the what is the problem statement you are trying to solve. And then of course we have integrating polishing and oxide growth steps, shortening cycle time and minimizing the contamination risk. So this is one innovation. If I talk about, okay, if I talk about the classification, it is under the heading of H10F 71/121, which relates to the active layers comprising group 4 materials. Then we have H10F10/146, which is back junction photovoltaic cells having integrated base emitter regions on the backside. Then we have H10F71/128, that is annealing. Then we have H10F71/129, passivating. Then we have recrystallization, which is again H. Then we have the Y IPC also. The Y IPC here is Y not 2P7 not slash 50. Manufacturing or production processes characterized by the final manufactured product. So, I already talked about it. It's basically polishing of a P-type silicon wafer, deposition, printing, blah 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 blah. It is printing a negative electrode on a non-laser ablation region on the back of a silicon wafer by using silver paste and sintering and drying to obtain a finished solar cell. And the temperature is like high temperatures used in this crystallization, which is controlled environment of 500 to 1000 degrees C. So you can imagine the kind of infrastructure needed just from the capital point of view if somebody has to deploy such kind of technology in India. So it's always better to work in a pool where the Indian government should actually have a very open conversation with the Chinese government and make sure it's not only an MOU. You need to um, you need to look into the MOUs which they have with Bangladesh. So the relationship between China and Bangladesh has to be taken into consideration. The relationship between, or the documentation which they have already done, please look into that. It's very, very important because China has done a fantabulous job both in, I would say, in Bangladesh and in Sri Lanka for that matter. So both these countries has to be seen and look into the factorial stuff of how this menace of this heated air in India can be stopped. And also we need to look into the aspect of the number of any kind of air kind of travel which is happening right now. The travel and everything, if not required, keep your carbon footprint low. It's very important because any kind of, just understand the heat is already there. And when fuel is utilized for the for from point A to point B, there is some kind of heat which is dissipated. So all these heat dissipation, until unless we have and deploy the technologies where we can actually energy harvest, not everybody would be able to understand this technology, what is energy harvesting, because energy harvesting itself has a lot of pros and cons and everything. But the whole ideation here is we need to deploy intellectual and intelligent folks who have been working in intellectual property rights in whatever capacity, and use them at the max to resolve the issues. I have been seeing the current changes which are being made. This is not going to make you know any changes in the way the SGD goals have to be achieved, which is sustainable development goals. And to achieve these sustainable development goals, we have to be sustainable with the technology which we are deploying. Assembling and telling it make in India is not going to solve the current issue. What is important is the pooling of technology and resources is going to solve the issue. And yeah, I think that is what I wanted to discuss. If I have to give another patent application, I would be giving. mm So this is detailing with the photovoltaic module, and this discussion is around. Again, it's a solar company based out in China. Preparation method of solar cells, and photovoltaic modules. Uh, I'll walk you through the abstract, and you can always look into the application whenever you are able to access the documents, and discuss with the respective government authorities how this can resolve, or how this kind of association can be collaborated, where we don't have to do the assembly in India, we have to have the end product with us. Because understand one thing, even when anything is deployed in India in terms of the machinery and everything, there is something called as environmental factors. You are going to see some differences. It's a similar way where Apple is introducing the products every 6 months. So what doesn't work, they just introduce. People in the background don't understand that, because people or folks like us understand the technology landscape very well. So this particular application is a method of preparing a crystalline silicon solar cell comprising a substrate, depositing a duped amorphous silicon layer on a first surface of the substrate. Then we have performing n successive layer treatments where n is greater than 1 on the duped amorphous silicon layer, as to crystallize it into n layer duped polysilicon stack extending away from the substrate, where the nth layer treatment uses lower power, longer wavelength, and fewer pulses than the n minus 1 nth treatment, which is where small n is less than equal to the capital N. And the resulting nth duped polysilicon layer possesses large silicon grains, that is n minus 1th layer. The first duped polysilicon layer, fine grain closest to the substrate, serves as a tunneling contact, and with the progressively coarser grained outer layer reduces the series resistance. So people who understand series resistance will be able to appreciate. Again, this is very technical jargons, or not normal people will understand, but people who should understand. If they don't understand, please, you can always put your question in the comment box. Somebody from our AI team will get back to you. So the entire stack is produced without any additional dopant activation and high temperature furnace step, thus simplifying the overall cell fabrication process. So in summary, if I have to summarize everything, um, we don't have to go to the basics. We are way ahead in the timeline. Just take a particular scenario, scene, embodiment, whatever, where we put this planet Earth on the timeline of time 2050 plus plus. So if you imagine what was the weather condition and what was projected in 2050 has been achieved in some part of the world because of so many reasons. I don't want to get into it. What mitigating steps of SWOT analysis can we, uh, you know, forcefully forced on everyone in the year 2050? That is what we require right now. And we have to collaborate with our neighbors. And our neighbors, if we just talk about India, it has to be Bangladesh, China, Burma, all the Asian countries. Sri Lanka is going to play a very pivotal role, because already China has built so much infra, and their collaborations are doing wonders. What is shown on the television is just to make people realize what is not happening at the back end. What I'm talking is the real stuff which happens in the back end. Thank you for watching out the video. Have a great day ahead.